So, soon we're ready.
There.
Now.
Hi, and welcome everyone. My name is Erica.
And I'm Tobias, and we are from Omegapoint, and we do penetration testing and security reviews. But we also work as developers, writing and maintaining code and help teams with application security.
In this presentation, we will demonstrate how tests can help us build secure APIs. And all the code we will show today is available at the GitHub repository. The demos will be written in Java 23, Spring Boot, and Spring Security, but the concept that we will show will be applicable in any framework. And we also have a repo for .NET as well.
Yeah, and when we do security reviews and penetration testing, we often find that tests with the security in mind is missing. And I think it's a missed opportunity because it's both very powerful and effective to write tests that verify that your defenses works as expected. Before we look into tests, we need to talk about why pen test tends to find the same kind of vulnerabilities over and over again. And this is a good way to show that. This is the OWASP top 10 for APIs. It's a list of the most common vulnerabilities found in APIs globally. And we can note that 4 out of the 5 on the top list here is concerned with broken authentication or authorization in some way. So it's obviously hard to get authorization right. This is nothing new. It's been known for quite some years how to address them, what the issues are. But why is it so hard to get this right? We find that many of these security issues on the list here originates from unclear, non-functional requirements and lack of tests with security in mind. So if we found those issues during development and testing, we will simply call them bugs and not vulnerabilities. So how can we address that?
Wouldn't it be great if we could catch all these security bugs just as early as we catch any normal bugs before the application has run in production for a while? Here we have a pen test report where the findings are represented by the red, yellow, and green lines depending on the risk. And we take those and refine them and put them in the backlog. But even if vulnerabilities are just bugs that are waiting to be fixed, there is a really important difference between security bugs and normal traditional bugs. The traditional bugs of our functional flow will probably be reported back to us by our users if something doesn't work. But a security bug probably won't be reported, and any malicious attacker or user that exploits it will probably go undetected because intrusion detection is really hard. So the vulnerability will stay open in production for a really long time, maybe until someone does a penetration next time. And if we think about vulnerabilities as bugs, then security is just like any other non-functional requirement that it should be part of our regular quality assurance process with backlog refinement and prioritization and all the other things that we as teams normally do. And here we can see that the team has tagged the security bugs with the blue label, and they have also prioritized the 2 most critical ones for the next upcoming release.
Yeah, so with this we want to point out that security and quality goes hand in hand. But how can we as developers assert high quality in the applications we build?
Our industry has well-established pattern with practices for quality assurance. One of those are test-driven development, and we will demonstrate how to use the TDD thinking in the application security today to help us find security bugs during development rather than after it has been deployed to production. And note that we are not saying test first, but we are saying test before deploy to production. It sounds obvious and simple, and most people do implement automated tests, but we rarely see tests with focus on security. Well-written test cases will help us identify the boundaries of our functionality, and if we have a hard time writing good and clear tests, then we might have an issue to understand our domain properly.
Yes, or put in another way by Bruce Schneier, some 25 years ago or so, you can't secure what you don't understand, and tests will help us understand and define exactly how a function should work, not just a happy case. So now let's look at how we can apply test-driven development thinking to application security. And First, we need a little bit of context for the demo that we will show later. And we have a set of APIs, 1, 2, 3, and we have some different users where the administrator should be able to reach all APIs, and the user should reach 1 and 2, and we have the service integration that should only be able to reach the API 3. So we need some way to restrict the access so that each caller should get the least amount of privilege or the least amount of access possible. And if we look at the basic requirements for this context, we could express this with just one line like this. Callers should be able to consume the APIs. Because this would meet any functional requirement we have. We could verify this with normal functional testing in a test environment. And when it works, we can do all the functionality that we want to do. Then we can safely deploy to production, right?
Well, we note that the regular user, or we note that the requirement is not clear, because the regular user with this requirement can use the API 3, which should only be intended for administrators and services. So instead, we could express the requirement as callers should only be able to consume the APIs needed for the required functionality. And this sounds easy and completely obvious, but teams often do fail to identify these test cases that we need in order to avoid vulnerabilities. And it's essential for security that we have identified the boundaries that we have in our requirements.
Yeah, because this is what attackers do. They simply try to misuse our functionality that we built and break out of the boundaries and execution context that we have designed for. But it's hard for teams to switch to the mindset of the attacker where they are looking to abuse their own system. And if we instead think in terms of boundaries and well-defined domain rules, we can minimize attack vectors without being experts on attacks. So how can we verify that callers should only be able to consume the APIs they need?
And for this, we have a negative test case. The user should not be able to consume API 3, and this will assert that the user can only reach API 1 and 2. Another example of this is tenant isolation. The requirement could be the user should only be able to access data within her own organization. And we rarely find these requirements or test cases when we do a penetration test to verify tenant isolation. But most teams that we meet list this as the top threat among when we talk about their threat model. And it is the number 1 on OWASP top 10 list for APIs for a reason.
So now let's look at what we mean by a secure API. And this is a model that we have implemented in the demo that we will look at. And you can, of course, implement a secure API in many ways, but you need to handle these 6 steps in one way or the other for all requests. The first one is to assert that we have a meaningful, valid HTTP request. We typically get this from infrastructure. We could have firewalls and gateways in front of us that we don't show here, but it's also the web server we're running and the web framework we use. This should simply be configuration and hardening from our side here, no application code. And sort of the same with step number 2 here. We should use a framework where we have a good trusted component for validating a JOT, for instance, that we use in this demo. So this is typically also configuration. We'll show that in the demo. And then we have step 3, where we go from the limited information we have in the token to a rich permission set, so we can do fine-grained authorization. For some applications, this is not much code, perhaps no code at all, because the access model is really simple. But for more complex scenarios, this could be a lot of work to get the right permission set, and we will show code for that as well. And then we have step 4, 5, and 6, which is the sort of normal application code that we work with as developers, where we validate the input data and do the authorization, the fine-grained authorization for access to the operation and access to the actual data. And if you miss this last step here, the step 6, they could be in different order, but if you miss that, then you have this number 1 on the OWASP top 10 list, which breaks tenant isolation, perhaps the so-called IDOR or BOLA vulnerability. And we will show good patterns in the demo and tests to help you avoid that mistakes. So how do we figure out what tests we need in order to cover this well?
Well, for this, a good place to start is the OWASP Application Security Verification Standard, ASVS, or the Web Security Testing Guide. With those, we can create a sort of security testing baseline, which will help us identifying the test categories that we need. For this demo, we have represented the most relevant ones on this slide. And for your application, you might identify other categories such as compliance or regulations or performance.
Yes, and this is how we will use it. And here we have the API to the left, and then we have the test categories to the right, and we will now add tests to verify that we cover these test categories, and we have tests to cover the steps in the model here, and verify that our defense layers works. And we will have unit tests and system tests which runs against a deployed instance of the API. And we will start by looking at the system tests, and they will cover authentication of the request and basic parts of authorization, and also some aspects on transport layer security. So it's time to switch to the demo, and we will start with the looking at the system tests.
Yes, if the computer wants to be with me. There.
Yeah.
So we have an application written in Spring Boot. I've just started it here, and we can see that we are running on HTTPS. It's 2025. It's time for us to just leave the HTTP beside even during local development. So we can then run all the system tests that we have already written. So
let's see how it goes.
Yes.
Yep, some green and some red.
Yeah. So let's take a look at the controller.
Yeah.
So up here you can see the products controller. We have a root, which is API products. We have one endpoint, which is a get endpoint that takes in an ID, the product ID. By the way, do you see? Or let me enter presentation mode. Yes. Better? Great.
Yep.
Yes. So yeah, we have one get endpoint which takes in an ID, and it fetches one. Oh, this I didn't want. And it takes in a string and puts it down to a repository in order to fetch a product that might or might not exist. If it doesn't exist, we return a 404 not found, and if it exists, we just return an OK with that product.
Yeah. So this is quite simple and naive code. But this pattern is what we often search for when we do code analysis and penetration tests to see how we can get an input string like this, and maybe it's passed on to the repository, because that might lead to an injection vulnerability in the repository if it's not treated correctly. And then we have some other things about the code that we want to highlight.
Yeah. It's a rather weak implementation, actually. We take the real input data and just push it down to the repository. This might be fine that you have in your repository, for example, parameterized SQL queries or such, but you really shouldn't trust user data. And often we see that it's being used as code somewhere down the line. We also don't have any specific authorization on this specific endpoint. It might be configured somewhere else, but we don't see it here, and that might lead to vulnerabilities. And we also see that we are actually returning the product domain object and not a data transferable object or DTO, and that might lead to that we have data leakage, that we send out data that were only intended for internal use.
Yeah, so now it's time for us to look at the system test we have and see what we cover with those.
Mm-hmm. Yeah, so here were the system tests that we just run.
Yeah, and there are many green, but some are red. So let's we start looking at the health test that we have.
Yeah, so we have a health test that testing an endpoint or a controller that has two endpoints, the live endpoint and the ready endpoint. So if we are anonymous, the live endpoint should return no content, basically just returning the no content response header without any body. Then we have, when you're anonymous, the ready endpoint should return unauthorized, because if you are authenticated, the ready endpoint will return some runtime information, and we don't want that to be done when you're anonymous.
And that's really important, because that the anonymous, allowing anonymous the liveness, only sort of a ping endpoint, because these ready endpoints, they might sort of grow over time, and you add more and more information. Perhaps that could be a vector for denial of service, because it's also make database calls, or it could leak some internal information.
Yeah, we recently, I don't know if you've heard, but Volkswagen had this vulnerability where they had configured their actuator endpoint to allow the heap dump endpoint to be open to the public. And the heap dump endpoint, as you know, will basically read out all the credentials that you have, and they found some AWS credentials and whatnot, and the breach was a factor. So you need to make sure that you don't leak information, and that you secure these endpoints for that reason.
Yeah, and writing tests like this will help you sort of limit that risk, or be the first one to detect that you have misconfigured your application. And yeah, another interesting test where you can leak information, that's how you handle errors. So we take a look at the error test.
Yes. So we just want to verify that when we are throwing some kind of exception, that we don't leak any data that any attacker would use, basically database credentials or something else. So we have created an endpoint that just throws an exception in order for us to verify that the data from that exception is not leaked in our API. So we have an endpoint called API error, and we make sure that if an exception is thrown, it should not return any details. Spring Boot helps us with this, giving us this nice error DTO with just status error and the path it happened and the timestamp. So we just verify that the content is only that and nothing else. And we also verify that if you're anonymous, this should, again, throw an unauthorized, just because we don't want regular users to throw exceptions in our applications. It should only be done by us when we do testing.
Yeah, so you might log the details, but you should never return them. Just return strings you have full control of. And also we can go back to the health test, and we had some that was on transport layer security to know that we run the correct version and so on.
Yeah, we have one for actually one with the token to verify that an invalid token should also get unauthorized, just as a side note. Then we have some system tests that require some kind of reverse proxy. In this case, for example, Nginx. So we require HTTPS. That test is really important. It won't run right now since I'm locally. Some of these tests will fail. That's why we have disabled them. And if you also verify that you're running TLS 1.3, so you don't allow any old versions. So here we just create a lot of clients with old versions, and basically at the end ensure that they don't work. And also we have a test that verifies that we are getting the proper security headers, and there's really good documentation on the OWASP about that.
Yeah. Which you need to set for a REST API. And so with this test, we have sort of covered the basics. We don't accept any invalid tokens. We have good TLS quality and so on. And now we can look at the products controller and the system test we have for that.
Yeah, if we start with just looking at the products test, we can see that the get by ID for when you're unauthorized is going green. That means that we will actually get unauthorized if you don't have an access token. And this is because Spring Security helps this with us. Just adding the dependency and everything requires a token, unless you configure it differently. And then also we can see that if you have the correct scope in your token and you do a successful request, you will get the 200. But we do have one test that is failing, and that is the when you don't have the right scope. If you, in this case, have a write product instead of a read product, that you get unauthorized, but we don't.
Yeah, so this shows the importance of the negatives test that we mentioned earlier. Without them, we might have deployed this to the production, because all tests had been green for the product's controller, and we would have an IDOR or BOLA vulnerability in production. And we will come back how to address the failing tests later. And now we will go back to the slides. And the system tests that we have showed covered authentication, authorization, and transport layer security. And And well, you could of course argue that JSON token validation is part of authorization, not authentication, but that's not important to distinguish in this presentation. So we move on to the unit tests, and we have the first set of unit tests here are for the controller and the get product by ID endpoint. They will address the responsibilities that the controller has, and we connect those to the test categories data confidentiality and integrity. So go back to the code and let's have a look at the unit test for the controller.
Yes, let me. There.
Good. And
so we will. Yes, presentation mode. That's correct. Thank you. Nice. We will start with running the product controller test. And these are unit tests.
Yes.
So
and not that good.
No, a lot of green. But the happy case is green. That's nice.
That's always green.
Yeah.
Because it's a happy case.
Yeah. And yeah, so we can look through how that looks. Product controller test. So we do some setup first. That's not relevant. So if you have the happy case, when it's success, you will get the 200. Yeah, that one went green, so we don't have to focus on that. When we don't find any data, then we should get the 404. So we set up to not find any product, and you will get the not found status code. If you don't have access to the data, then you should get the forbidden. Or if you don't have any permission to execute that operation. And if you don't have any access to that data, for example, the product I'm trying to read belongs to another market than I am, then I should get not found. And sorry?
Yeah, and you could choose there on how what you should return. If you should return a 403 or 404 when you don't have access to data, but if you go for 403, then you will expose that this object exists. In some contexts, that's perfectly fine, but in others, you wouldn't want to leak that information. So good. The correct response codes are important for monitoring and things like that. So this is important for security.
Yes. And we also have some tests to verify that if the user sends in some data that is not valid, that we get a bad request. And also we have a really important test at the end that if you do the successful flow, you should return the DTO and not an internal product. And this one fails because we are returning the domain object.
So yeah, and once again we have a lot of failing tests, and we will address them later on. And we go back to the slides to see where we are. And so the next set of tests. They will concern this transformation step, the step 3, where we go from the token information to our access model. And the access model in this demo is that you should only be able to access products for a given market. We have the Swedish market and the Norwegian market, but we should only be able to reach the Swedish products as a user. And yeah, so we go back to the code once more, and we look into test for this, and focus on the permission service, which handles this transformation.
Yeah, so many frameworks, and Spring among us, it kind of leads us down a path where you have a user object that is injected into the request chain and brings back some kind of key value map that you can query to get, like has authorities in Spring, for example. But we say that it doesn't have to be like this, because this key value string doesn't really help us anymore. Like, it doesn't give us this fine-grained access control. So we have instead opted for creating a specific permission service. And in here we encapsulate all the permission, like all the authorization decisions that we want to use. So the first 4 variables are connected to the user. We store the user ID, client ID, which authentication method, and the product it belongs to. And we have 2 permission-related objects, which are can read products and can write products. And with this, we can create then methods. So if we scroll down, we have this can read product, where I send in the product, and it checks basically, is the product belonging to my market, and returns the decision based on that. Yes.
Yes. So if we look at the hard-coded market ID there, this would normally be like a database lookup, for instance, so to check which market the user has access to. It could be a service call, or sometimes it's just static in memory, sort of configuration or a configuration file. But with this, we have a good centralized pattern for dealing with the permissions, and we also can now use this strong typing that we have in our language, and not just have this string key value map. And yeah, so this is of course vital code for security, that this is absolutely correct, so we don't handle out the wrong permissions to the wrong users. So let's run some tests for this and take a look at that.
Yep. So we have unit tests for these. And this is why it's really nice to have a permission service. You can unit test those and you know it's correct. These things that we have in Spring with pre-authorize and stuff, they are quite hard and clunky to try out just those. This is really easy to test, and we have verified that we have a strong implementation because all of the tests that we have written are okay. It's just about, again, how to set up the access. So if you're an anonymous, you should not have any access set. If you're an authenticated user, you should not be able to read products from another market. That's the IDOR vulnerability we talked about. As an authenticated user, I should be able to read products from my market, and that is the happy case. As an authenticated user, I should read products if I have that permission in my access token. And we also check that if you're an authenticated user, these identity properties like user ID and everything is actually set properly. And we also have a specific test where you have the wrong scope. We verify that you are actually being denied if you're misspelling the permission or anything.
Yeah, so all is green, and we go back for the final test categories. And this is the unit tests for the domain layer, where we have all our application logic. And it will cover authorization, data confidentiality, integrity, and accountability. So we go back to the code once more, and we will take a look at the tests for the products controller. Or we will look at the products controller first.
Yes. We start with the products controller. So you've seen that we've run a lot of failing tests. Now we're going to try to see. Oh, I'm not. Oh,
thank you.
Thank you. Really good to say that.
So
That's PowerPoint doing magic to me.
So
And there. Yeah, thank you.
Good.
Much better. Yeah. So now we will try to fix things, right?
yeah, and we will start by adding some input validation, where we have some failed tests earlier, if you noticed that. So we have some business logic that tells us that a product ID can only have a certain format. So we want to assert that and abort the request early. And we will, Erika will add code for that.
Yeah.
And yeah, so and if we don't have a valid format, then we will return the correct status code.
Yes. So what I've written here is that basically if the ID is empty or null, or if the length is more than 10, or if it doesn't have any alphanumeric values, then we should return a bad request.
Yeah, that looks good, but as we all know, if we haven't tested it, then we might have a bug here. So it's best to run the test and see if that improves, and that the test for input validation is green now.
And that we have for unit tests, so
Yes.
I don't have to restart, but I accidentally did anyhow. So let's rerun the unit tests, and we can see that the 400 is actually going green now.
Yeah. Good. So so this works. We verify requirements for a product ID, but it's easy to do mistakes in code like this, and a stronger pattern which we can use when, for instance, when we have multiple endpoints and the application grows, is from domain-driven design and domain-driven security, and that's by introducing domain primitives. Because our product ID is not a string that can contain any character, we should use strong typing and treat it as a product ID, not a string. So we will add that to the.
Yep. Here we have a product ID class that actually does the same validation as we did in the controller, just the other way around, and assert that in the constructor. So if I send this in, this will allow us to know that if it is an actual product ID, we know that it's valid, because it will throw an exception if it's not valid, so we can never construct this without it being valid. So let's use this. So instead of this nasty if case, we can say that if product ID is not valid, then we should do this bad request again. And then as soon as we're done, we should go towards the domain primitive instead of the string. So let's create this product ID and start using that one instead.
Good, so this gives us a better pattern for input validation, and we should note, however, that using domain primitives is not only about input validation, but we will not cover state changing functions and sort of domain logic and state today. And the same reasoning that we used for the product ID should of course be applied to other strings or things that we use, like the product name and so on. So we have a class for that as well, but we won't show that. And we also have some unit tests for this, because it's domain primitives lends themselves very well for unit testing. But now we will start looking at the authorization part, so that we need to address. We had a lot of failing tests concerning that, and we could, of course, add code if we look in the controller for fine-grained access control with if statement, like we did there. But a stronger pattern that scales better is to have a service layer or a domain layer where we do this. So we will start by adding a product service.
So we have a product service, and it has right now only one method that takes in the domain primitive we created earlier, so we know that this is valid. And then we start with checking that you have the correct permission, that you can read products, otherwise we bail out. Then we go to our repository, and if we find it, then we return it, or otherwise we will throw an exception saying we didn't find it. And we also have the last step, the step 6, that we can read the actual product based on the market information that we have stored. So here we use the permission service that we earlier created.
Yes, so and also notice the importance with a clear pattern and the order. So we abort early before consuming system resources. We get the input validation by using the product ID. We check the permission to do this particular operation, or we abort. And then we need to access the data in order to know if we have access to that particular product. And if we don't have access to then we abort. And then we could do perhaps more heavy processing and domain logic consuming system resources. And also notice the audit logging, which also is an important security aspect, so we know who has access to what product and or policy violation for intrusion detection and so on. Yeah.
Should we use it?
I think that's a good idea. It looks good. Let's use it.
So let's remove this, and we have already injected the product service, and we do this get by ID with our product ID that we have. And in back we get the product, and instead of an optional, we will just return that one. Nice. And also to verify, like we throw some exceptions in the service, and for that we have a global exception handler that basically checks all those exceptions and maps them to the correct HTTP status. It's a Java thing. You can say what you want about that.
Yeah, there are different ways to do this. The important thing here is that we handle the 6 steps and the security aspects that we talk about. And then, so now we've done a major refactor. Let's run the tests again.
Let's see.
And see if it improves.
Drum roll, please. Oh, nice, but there's still one.
Yeah, that's easy to miss.
Yes, and that is, as you can see, that we should return the data transferable object. So for this, we have created a DTO and a mapper. So we have product mapper, and then we do this to the product DTO. And for this, we need to actually return the DTO here. And one thing to note is that the DTO doesn't contain the market, for example, because we said we didn't want to leak that data. And if we rerun, it should look green.
Good. So now we can run perhaps all tests and see if we're all green. And maybe we're done, right?
Exactly. So let's see.
Yep.
If we scroll up, you can see there are the unit tests look really good.
Yeah.
But the
But there
systems.
is still some tests failing, so we need to address them, and we will start to look into the failing tests in the health controller, and we see that the test with the invalid token is failing.
Yes. And that is because Spring Security doesn't automatically validate the audience. So that is something that we should do. So for the security configuration, we will add the audience validation. Basically, we verify still the issuer as Spring Security does by default, and then we validate that the audience claim over here has product API as the audience.
Yeah, and it's important to verify that the token that is issued is issued for us and not for just any application that comes from the same issuer that the token was created at. So this can be done with the audience and the scope verifications. And so let's run system tests once more and see if this fixed the problem.
Yes. This was a live template, so I put it in. I TV cooked.
No, she's really fast.
Yeah, exactly. I'm really fast. No, it's Copilot, you know.
Yep. So, good question. So let's see how it goes.
Yeah, it doesn't want to, but you can just trust us that that test will still work. But there's one test that is still failing, and that is that the regular live endpoint still is going red because we want to have anonymous. And for that, we need to update the defaults that Spring Security helps us with. So we have the default security filter chain that the Spring Security adds for us, and they're really nice. And this default over here, any request authenticated, is what blocks any anonymous access to our API. But in order to open up, because we want to open up a live endpoint, we need to add some additional matching. We don't go into the details, you just have to trust us that it works. You can look into the repo yourself. And with this, it should all fix all our problems.
So let's see.
Yeah, let me stop everything.
Yeah, we need to restart and run again. And
my IntelliJ don't want to work with me right now, so I just need to restart it. But we can check that it works afterwards.
Yeah, and so. While we restart there, it was all green, and yeah, it's restarting. Good. So that's one final step here. We have done the authorization part in the service and domain layer, and then, but also we talk about it's important to abort early, and of course Spring Security has a good way to do that, and that is using the pre-authorized tags. So for defense in depth, we will add that as well, so we can abort if we don't have the permission to access this particular operation. But we should note that this does not replace the need for also asserting this in the service for a strong solution with defense in depth. So we can always have access this permission check even if we fail to add this, or if we use this service and domain code from another context, not from a controller.
Yeah. It doesn't want to play with me, but trust us that it works.
So it's great with live demos.
Yes.
It's always a little bit exciting.
Yes.
So all is green.
Yes.
And we go back to the slides. And so with this demo, we have shown that with a reasonable effort, we can cover the basics part of security testing, and we can use TDD thinking for application security. And yeah, then we'd also address most of the issues on the OWASP top 10 list that we started to show you. And we think that none of the tests that we have shown here is hard to write. They are selected with a little bit of care and thought, and we need to verify the boundaries of our application and the requirements we have. And now it's time to summarize this.
So tests will help you understand and identify the boundaries that you have. Automated tests will make sure that your rules and the defenses are applied accordingly and implemented correctly, as we've seen with this iterative process. And this is really vital for security.
Yeah, and writing a test is really important because, as we said, many of the vulnerabilities we find originates from unclear, non-functional requirements and missing test cases that allows an attacker to break out of the boundaries and abuse the application. So if we write the tests, the bar for the attacker has significantly, it's been made it really harder for the attacker. And we hope that this presentation has inspired you to write tests with focus on security. Maybe start with a few system tests like we showed. And also note that you could run those in production, asserting that you don't have an open endpoint in production.
But will it scale? I mean, there was about 50 tests for every single endpoint.
Yeah, a lot of tests and quite boring to write, if you ask me. but as always, our investment in security should be proportional to our business. And based on our experience, this implementation with all the tests are a reasonable level of security for most businesses, because no APIs should be vulnerable to the OWASP top 10 vulnerabilities. And yeah, that was really all from us. And
but many of the things that we've talked about here today is really written really good in this book, Secure by Design, written by our colleagues Dan and Daniel. It's a great book that we recommend if you feel like you want to read a book. If you don't feel like reading the book, they have had a lot of J-focused talks that you can look through instead. Yeah, and that was everything from us. If you want to take a closer look at our repo, then you can find it here. And also please rate our talk.
Thank you.
Thank you.
Thank you, Tobias and Erika. We have a gift for you that will be a charity. So one for you, Tobias, and one for you, Erika.
Thank you.
Is there any questions for Tobias and Erika? You're welcome to ask them now before the lunch, if you're not too hungry, of course. Hands up if someone...